So more momentum examples. Oscar, what does 1A want me to find?
Change in momentum.
Another word for which is?
Impulse.
So, you know what? At the top of the page somewhere here, I'm going to write impulse equals impulse. Where this one here is really, what's change in anything? Okay. Which one am I going to use? Am I going to use the force times time, or I'm going to use final minus initial? Well, let's go look at the question. Oscar, read number 1 to yourself. What's that 8 that they gave me? What is that? What are the units right next to it?
Newtons.
So what must it be? Ah, you know what? I'm going to say, I think I'm going to use force times time, not final minus initial. Did they give me a time as well? Oh, then yeah, we're home free. Okay, so it's a process of elimination. Look what they gave you. So if you push on an object with 8 newtons of force for 10 seconds, what will the change in momentum be? 80 Newton seconds. Or 80 kilogram meters per second. I don't care which version of the momentum units you use. In this case, though, since I went force times time, it's technically more correct to give your answer as Newton seconds, but I'm not that fussy. Oscar, you're on a roll. Keep going. What does B want me to find?
Object's impulse.
What's another word for impulse?
Change in momentum.
What did I find in part A?
The force. The change in momentum.
So what's the answer for part B? Yes. Say it loud and proud. What?
80.
All I'm really doing is I'm trying to emphasize that when you see the word impulse, another word for impulse is what? Change moment. Because every year I ask someone on the test, find the impulse, and kids leave it blank. And I know if I'd said find the change momentum. Okay. What's part C want me to find, Ange?
The change in velocity.
Okay, now I'm going to use the other version of impulse, because we also said that the change in momentum was, what's change in anything?
Final minus initial.
And what did we say momentum was? What times what, Madison? You told me this about 60 seconds ago. So this is the same as mv final minus mv initial. That also is final minus initial. You okay with that, Spence?
Yeah.
Or I could write it like this. M change in velocity, because that is final velocity minus initial velocity. And this question said find the change in velocity. I could write it that way. Now on the left-hand side, what is that delta a symbol for? In fact, this is change in momentum. Another word for which, Oscar, is what? Change momentum, another word for which is what?
Impulse.
Impulse. And how big is the impulse?
80.
Oh, you know what? I can just drop the 80 right there. That's what I was kind of getting at, right? What did this question want me to find, Ange?
How will the change in velocity?
How would I get the delta V by itself, the change in velocity by itself? Please tell me, did they give me the mass in the question somewhere? Because I haven't used it yet, but is it there somewhere? Woohoo! Okay. If you push on an object with a mass of 4 kilograms with 8 newtons for 10 seconds, by how much will you change its velocity? Let's find out. The change in velocity is going to be 80 divided by the mass. 4. Spencer is reaching for his calculator and disappointing me. I would argue I can do 80 divided by 4 in my head. What?
20.
Now here's what that means. What that means is if you started at rest, after 10 seconds, you'd be going 20 meters per second, because that's your change in velocity. Or if you started at 15 meters per second and your change in velocity is 20, after you'd be going 35. 15 plus 20, 35 meters per second after 10 seconds. Because I didn't tell you what we started at, but I can tell you by what how much we changed by. A snow scooter has a mass of 350 kilograms. Check. A constant force acts on it for 60 seconds. The snow scooter's initial velocity is 2.5 meters per second, and its final velocity is 18 meters per second. Kyle, my friend, what does this question want me to find in part A? Okay, I'm going to write this. Now, I got two options, remember. I can go force times time, or I can go mv final minus mv initial. Which one am I going to use here? Well, I go check. Did they give me the force? By the way, when I say did they give me the force, what am I really looking for? What magic letters somewhere in the question? And for newtons. Did they give me anything in newtons? Okay. Now, I might be able to calculate it. Did they give me a mass and an acceleration? Because that's also force. I see a mass. Did they give me a meters per second squared anywhere? No, you know what? Don't write this down. I'm not going to use that one. So I'm going to use the other version of impulse, which says change in momentum is, change in anything is final minus initial. Double check. Did they give me the mass? Did they give me V final? Did they give me V initial? And then the only other thing I have to be careful, because you'll notice I'm being much more careful with my vector notation. Thomas and Carson and Noah, we said momentum is a vector. We're going to have to be, not like energy, which was a scalar. We're going to have to be way more careful with our vector notation. Is there a change in direction in this question? In other words, was I once going left and then I'm going right or anything like? Because if that happens, I have to let one way be positive, one way be negative. I'm reading this. It doesn't seem to hint at any change in direction, but that's a preview of coming attractions, by the way. We'll start to look at that in a second. Okay. Kyle, what's the mass? You, Kyle. Yeah, you started this.
Yeah, 350.
What's the final velocity?
18.
Yep. Minus. Mass was 350. What's the initial velocity? Spence, I'll let you use a calculator for this one. Or can I do it in my head? That's going to be 350 times 15.5. Ooh, yuck. It's going to be 300. Boy. Okay, it's going to be 3,500 plus half of that, which is going to be 5,250 plus half of that. 5,425? Or am I totally off?
Yeah, you're right.
I am?
Yeah.
Who needs a calculator? Come on. I'm kind of impressed with that one because that was 3 sig figs. Units, momentum, kilogram mass times velocity, meters per second. And again, Cade, if you said Newton seconds, I'm fine with that. The only argument I would say is since we went MV to find it, let's use MV in our units. That's more appropriate, but they're interchangeable. Kyle, you're on a roll. Keep going. What does B want me to find? The magnitude of what? Okay, let's try that again. What does B want me to find? I think I'm looking for a word that begins with the letter F, force. What did I find in part A? Another word for which is? Begins with the letter I. Impulse. Okay. Do I have an impulse version that has force in it? Why, yes, I do. Another way to write change in momentum or impulse, another way was that one. Right? What did you say we're trying to find in part B? Can you get the F by itself? Okay, so the net force is going to be the impulse, the change in momentum, divided by the amount of time you're applying said force. Do I know the impulse? It's what I found in part B. 5,425. Did they tell me the amount of time? I bet you that. What? 60? Oh, 1 minute, 60 seconds? Do this one in your head, Mr. Dueck. Okay, I'll try. Ooh, it's going to be 542.5 divided by 6, which is going to be, you know what? I'm running into a couple of repeating decimals. I'm going to give up here. $90.4? 90.4 what? Newtons. Direction. Oh, I said magnitude because I didn't give you any direction in the question. That's why I added the word magnitude in there. Okay? In other words, if you want to change the velocity of a snow scooter that weighs 350 kilograms from 2.5 meters per second to 18 meters per second, and you want to do it in 60 seconds, your engine better be able to exert 90.4 newtons of force minimum. Otherwise, it can't be done. Okay, so there's lots of overlap here. There's two ways to think about change in momentum or impulse. Okay. Oh, number 3. Number 3. Natalia, my angel, what's number 3 asking me to find?
The final velocity of the rocket.
Okay. Oh. What's the initial velocity?
0.
Yeah, it's convenient, right? We've seen that word enough times now that ding, 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 ding. Okay. By the way, I just clued in yesterday, or last day, I was really tired because I kept calling you Tash for some dumb reason, didn't I? Yeah, and you were looking at me funny. And my brain just picked up on it now, which should both frighten you about how my brain works, but also please you that I caught it at least. Yeah, whatever. It's towards the end of the year for me, too. I'm pretty tired. What did you say they want me to find? You know what? Then I think I'm going to end up going MV final minus MV initial. Yeah, the grade 7s are here. Can I have your attention here, though, folks? We're good. Is that okay? Oh, and this is impulse. Now, the only problem is, did they tell me the impulse in this question? Do I see anything with kilogram meters per second next to it? Or Newton seconds next to it? I saw Anne shake her head. You know what? I'm actually, I think, going to have to go like this. Force times time equals mv final. What happened to the minus mv initial? What did you tell me v initial was? So do you mind if I do that right now? Now, did they tell me the force in the question? Did they tell me the time in the question? Oh, and they told me the mass, I assume? Okay, so now we're looking a little bit about, this is some rocket science, okay? So that net force would be coming from the engines. Now the only problem is, in real life, a rocket is much, much tougher because as the rocket burns fuel, what happens to its mass? It gets lighter, and we can't handle that right now without calculus. So anytime I do rocket science, I do want to point out I'm having to fudge things quite a bit because we can't handle, the mass is changing, so that would mean your acceleration is actually changing because F equals ma. If m gets smaller, a gets bigger. Anyways, what did you say we're trying to find? How would I get the v final by itself, kiddo? It's going to be the force times the time divided by the m. And you'll notice out of sheer laziness, I dropped the delta in front of the time. Why? Just because time's always a delta. I won't be fussy if you put it there or if you don't. It looks like I tend to put it there if there's another delta in the equation because it looks prettier and more symmetrical, but I can't even give you a good physics reason for doing that. No way, it just looks prettier. What's the force? 2, 3, 1, 2. I think 23,000. 2.3 times 10 to the 4th, 23,000. What's the time? 2 minutes, 120 seconds. What's the mass? 26,000. Do you get 106, I'll say 106 meters per second? Okay. So if you are working for NASA, do you know how much force your rocket engines put out? Yes. So could you use this? Yes. Oh, but again, I have to clarify, Thomas, it's a much more complicated equation because as the rockets burn fuel, the mass is changing. You have a changing acceleration. So we really can't deal with that. Even with Physics 12 stuff, we really can't deal with it without calculus. What else can we do? All with this idea of impulse being another word for change in anything being, and also recognizing that another way to write final minus initial is force times time. All we're doing is mixing and matching that. A car of mass 1,600 kilograms moves at 32 meters per second. What braking force is needed to bring the car to a halt in 1.6 seconds? What's this question wanting me to find? Okay, so I'm going to write, since it wants me to find the force, the impulse equation that has force in it. Although, do you notice, Amy, there's also some velocities in here too? If you wanted to, you could have gone straight to saying impulse equals impulse. Because change in momentum is final minus initial. Which final? Which initial? Velocity, because momentum, Jordan, is mass times velocity. So if you go straight to that second line, I have no problem with that, but it all comes from that top line. In fact, I think the equation that I give you on your formula sheet is the blue one. The rest we're just going to derive and mix and match. Is it the blue? Is it this one, Cade, that I gave you on your formula sheet? Since you have it there in front of you? Under momentum, did I give you FT? Can I see?
Yeah.
Yeah, oh, yep. Okay. I don't think I gave you this longer expanded one, though, did I? No. Okay. What do they want me to find here? I guess the force is going to be mv final minus mv initial over time. Now, the only reason by the way, I know that, what's the final velocity in this question? It says to a halt. What's the final velocity? So I could have canceled out mv final. I didn't on purpose just because way back when I told you that F equals ma, and that was Newton's second law, F equals ma, I lied. Newton was much more interested in acceleration and momentum. When he wrote his force equation, he actually wrote it this way in terms of momentum. And that's the only reason right around now I say, by the way, I fibbed. But that also, if you muck around with it, does turn into F equals ma, if you're clever. Anyways, we can go, ha-ha, because V final is 0. So we're going to get 0 takeaway, mass 1,600, V initial 32, divided by 1.6. Oh, this should work out evenly, because I got a 16 on the top and a 16 on the bottom. In fact, I should be able to do this one in my head. It's going to be negative. I got that much. That's going to be cancel. That's a 32,000? Yeah. 32,000 what? Newtons. What's the negative saying? If the car is traveling east, which way had your brakes better exert a force to stop it? West. If the car is traveling south, which way had your brakes better exert a force to stop it? No. And you guys know this. You've been in cars, but there's the physics of it. There's the proof. Okay? Because momentum and impulse are vectors. They will give you answers that mean something. 1, 2, 3, 4 more, we're done. 3 more, we're done. Fire hose. A fire hose pours 24 kilograms of water each second on a burning building. Any of you ever used a real live actual fire hose at full blast? Do they exert a force? So you know what? There's an impulse there because it's a force over it. There is an impulse there. Okay. Water leaves the nozzle at 60 meters per second, assuming that the spray of water does not bounce back from the wall. What's the minimum magnitude of the force on the wall of the building? In other words, it's saying assume V final is 0. Well, Colin, since you've used the fire hose, what's this question asking me to find? Yes. You could also have read it from in front of you, but I'm glad that you read it back. What's it asking me to find? Can you say it with some authority in your voice, like you know what you're talking about?
Force.
Force. Absolutely. Now, F equals ma. I don't see an acceleration in this question, because now we've got a new version of force, and we're kind of coming towards the end of the year, so I'll also review the old stuff. We've always done, hey, free body diagram, F equals ma. Here, the fact that I noticed they gave me a mass and a velocity, and they gave me time, although they were sneaky, they wrote it out. What's the time in this question? 1. I'm going to go like this. Impulse equals impulse. Change in momentum equals change in momentum. And I can go, because after the water hits the wall, final velocity is 0. What did you say they want me to find here, kiddo? How would I get the F by itself? I'll just drop the negative down because it's 0 minus mv, which is negative. It's going to be negative m 24 v 60 all over t each second 1. Please don't type the 1 into your calculator. 24 times 60, well, 24 times 6 is going to be 140, 1,000, negative 1,440? I'm on a roll. Units? What's the negative telling me? Whatever direction the water is traveling, the wall has to apply a force in the opposite direction. Okay? And this is why fire hoses are such a, although it looks very, very kind of tame, they're such a terrible way of crowd control in riots. If you ever see some of the old videos of the civil rights movement back in the 60s, when the police are spraying protesters with fire hoses, it's tremendously painful. It's oh, water! It's very painful. I like question 6. I like question 6. I like question 6. Question 6 is a nice question. Okay. Hey, Max, what's number 6 asking me to find?
VF.
VF. Speed, oh, and direction. Okay. And you know what? As soon as I see east and west, I have a habit of screwing them up, so I almost always draw a compass rose. The number of times I've gotten east and west mixed up would amaze you. North and south I'm pretty good on, but anyways. Now, don't write this down. Up until now, when they've said find V final, Max, we've done this. Read the question. First thing I see is a mass, yes? Which makes me suggest, since this doesn't have a mass, I don't want to go with this. The second thing I see later on is a force. You know what? I'm not going to use this to find V final. Instead, impulse. Force, change in time, impulse equals mv final minus mv initial. Impulse equals impulse. What did you say we're trying to get by itself, Max?
VF.
Okay, so I'll just put a little dot right there to kind of track it. So I need to move this over. How? Okay. Right? What did you say we're trying to get by itself?
VF.
How would I get the VF by itself?
By M.
You guys okay? I'm going to be really lazy. I'm just going to cross the M out, draw a fraction line, and put the M there right away, and just keep it on one line. Now, I don't know if you recall, but a few minutes ago, I did go on a bit of a rant about keeping your eye open for changes in direction. Is there a change in direction in this question? Kyle's nodding. So, Max, since you're solving this, you're going to decide one of these is going to be positive, one of these is going to be negative. It does not matter which one, but you're going to decide, and we're going to be consistent throughout the whole question. Do you want to let east be positive or west be positive?
West.
Okay, so I'm going to go make a little note underneath the west. I'm going to put a little plus, and above the east, I'm going to put a little minus. It takes 1 second, but that's your track to make sure you're not going glitchy. Okay. Plug and chug. By the way, which means if we get a positive answer, the answer is to the west. If we get a negative answer, the answer is to the east. Force, 350. That force, is it positive or negative? What direction does it say the force is? West? What did we decide west was going to be? So put a little plus sign in front. You don't have to in your homework, but let's in our notes make it. We checked. Time times a scalar, 0.075. Plus mass, 4.2. V initial. Now the magnitude is 4.65. What direction is V initial? East. Did we decide that was going to be negative or positive? Oscar.
Negative.
So I'll put in brackets negative 4.65 divided by mass. What direction is the mass? It's a trick question. Mass is a scalar, so no direction. What was the mass? 4.2. And you can see this makes both a great multiple choice or written question. There's lots of room to make signage mistakes, directional mistakes. So if I was doing multiple choice, I guarantee I would solve it once where you left everything positive. I guarantee I would solve it once where you had one would be positive and one would be, or I did something wonky with the signs, and that answer would be there, absolutely. Right? What's the final velocity? Sorry, what's the final speed? And then we'll interpret the direction. More than one number on the top, brackets. Divided by 4.2. Does it work out nice? 1.6? Yeah? No? Am I wrong? Somebody else got that? Yeah? Okay. Positive or negative? So I'll make a little note here, positive 1.6, and now I'll put an equals and translate this whole thing. 1.6 meters per second. Direction, we got a positive answer. What did you say positive was going to be?
West.
West. West. Ah! No, nothing? Last one. A lot of these will be appearing in your homework that I handed out last day as well. A rifle accelerates 12-gram bullets from rest. That's usually important. To 250 meters per second. The rifle barrel is about 0.85 meters long. Check. Find the impulse acting on the bullet and B, the force on the bullet. Okay. Jordan, what does part A want me to find?
Impulse.
What's another word for impulse?
Change in.
I got to be fussy. Not change in momentum. Okay. You know what? I'm going to write this then. Am I going to use the version with the force and time in it? Or am I going to use the version with V final and V initial in it? What do you think, Jordan?
V final.
Yeah. Okay, so I'm going to go straight to saying MV final minus MV initial. Oh, and in fact, hey Jordan, why can I do that? From rest. So the impulse that acts on the bullet, where does that come from? The gunpowder, right? Is going to be 12 grams. Look up. Is that 12 grams? That's 120. because kilo is 1,000. So 0.012 grams, sorry, kilograms. 250. Do this one in your head, Mr. Dueck. Well, okay. Multiplying by 250 is going to be the same as dividing by 4 and moving a few. Oh, is it 3? Even? Oh, my pen is doing so good. Okay, let's see if I can repair it. Pause. 3 what? I would either take Newton seconds, but since I went mass times velocity, I'm going to go kilogram meters per second. Okay? Jordan, what's B want me to find? Oh, you know what? That's going to be force change in time equals change in momentum, where the change in momentum is 3. Yes? So I know the change in momentum. Oh. What didn't they tell me? Even though this question says find the force, you know what I'm going to spend most of my time finding? Time. So I'm going to go a little like that. I'll get it started. I know it's going to be F equals impulse divided by time, so I'm all good to go. It's going to be 3 divided by, I don't know. So over here, I'm going to say to myself, okay, what else have they told me? Oh, VF is 250. Yeah, we're going back to our Dolphin DFIC, right? Our DFIC approach. VI is 0. Oh, and I heard you mutter. Have I got an equation that has VF, VI, D, and T in it? We hardly ever use this. 1/2 VF minus VI times T. Plus, thank you. Honestly, I use it so rarely, I don't have, this is actually the only equation that I generally don't have memorized. Physics 12, we maybe use it once. Is that right? Or I might have written it VI plus VF, but adding doesn't matter anyways, right? Okay. What did you say we want to find? T. How could I get the T by itself? Well, you know what I would do first? Isn't timesing by 1/2 on one side the same as timesing by 2 on the other side? And that looks prettier. In fact, I think I'll get this. I would divide by the bracket. Yeah? Now, it is true, I think Colin was going to point out, VI is 0, and I agree with that, but just to show you if it wasn't, here's your full derivation. But yeah, I agree, I could have crossed that out a lot earlier if I'd wanted to. I don't think we've ever gotten the T by itself with that particular equation, so yeah, kind of coming full circle. Do I know the distance? I think so. Okay, 85. Do I know the final velocity? 250. So apparently, I doubt this will work out evenly. 0.85? 0.85, thank you. That'd be a long rifle barrel. Times, Mr. Dueck? Divided by. That seems, yeah, it should be a small time. It doesn't take very long for a bullet to travel the length of a rifle barrel. So that there is, I think these are milliseconds, so 6.8 milliseconds, which sounds about right to me. 0.0068 seconds, and that's going to go over here. 0.0068 seconds. 3 divided by answer button. 441 newtons. That's a nice question. Also because since we are getting towards the end of the year, it's nice to review some of our kinematics stuff, our VF, VI, T, and A, and all that stuff. What's your homework? If you go look at this sheet that I handed out last day called Momentum and Impulse, for Noah and Tom and Thomas and Carson, we already circled number 1 and number 2, and number 3 and number 4, and 5 and 6. We can now add to our repertoire number 7. Here's our fire hose question that we did today. We already circled number 8. Then there's your scrambled answer. Then to your challenge questions, I already circled 1, 2, 3. 4, I had put a star next to. I think now we just did one like number 4, so you can hopefully handle it okay. 5 is good. 6, hey, let's look at 747 jets. Now, the issue here is going to be part A is find the force from one engine, and then if there's 4 engines, what's the total force? Multiply by 4, and then using that, I think you can find V final. Now, numbers, let's do this, Mr. Dueck. What kind of a graph is number 7? What's on the y-axis in newtons? Force. What's on the x-axis? You know what? This area here is the amount of work. This is actually a review from last unit, but we're getting towards the end of the year, so I'm going to say try that one. And now I'm going to... 8 is good. What words did I underline in number 8? There's a change in direction. You better let one of those be positive, maybe upwards, and one of those be negative, maybe downwards. Otherwise, you're not going to get the correct answer. Okay? So you got all class to work on that. Fine.